another revision session. Mathematics today. I'm ready. Lottie's ready. Ready lots. And today we're going to talk about square and cube numbers. This is used, I think in primary school this is taught to set children up for secondary school, but it seems to be a place where I see lots of marks getting dropped for no reason. So I'm going to go through it again today. Hopefully it's a refresher for you. If not, we'll teach it from the ground up. I'll show you some SATs questions. As I've said in the notes here, very useful in secondary as powers or indices are used. And we do see them in reasoning papers as well as arithmetic. Shouldn't be too complicated, but they are going to form the foundation of lots of questions when you get to secondary. Okay, so in simple terms, the small number that you see shows you how many times you're multiplying the number by itself. So here we've got 3 and a little 2. It's telling you to multiply the number 3 together twice. 1, 2. And that would be 3 squared. That's a squared. 3 squared is 9. 3 squared is the same as 3 times 3, which is 9. So down here, just to extend the example, this would be cubed, which is multiply the number 3 by itself 3 times. 1, 2, 3. We'll do that one later on. But you're going to have 3 times 3 and then times 3 again. And you would say here 3 to the power of 4. So you'd have 1, 2, 3, 4, and you keep going. Very useful up in secondary school. I will go through all the ways of doing that. If you aren't sure with square numbers, so I'm talking what would 4 squared be? Or if you're not sure if a number is a square number, you can see if you can draw it in a dot array. So 1 squared is kind of a square, equals 1. 2 squared, 2 that way, 2 that way, 2 squared equals 4. You can draw that in a square. You do 3 by 3, 3 squared equals 9. And onwards, if you want to do 4, again, you're going to do 4 rows of 4. If you need to count them up, and this might be what you need to do in a SATs or arithmetic paper, that's 4 times 4, because you've got 4 along the top, 4 along the side. 4 squared is 16. And you can do those dot arrays as long as you want. If you ever get stuck with a number, I wonder if 8 is a square number. Well, we can try and draw 8 in whatever way you want, but it's never going to make a square. So you could have a rectangle, but you're never going to be able to draw a square. And so therefore you know that 8 is not a square number. A cube number can form a cube. So actually, if we imagine a Rubik's Cube, or don't have to imagine it because there's a picture of it right there, you've actually got 3 along there, times by 3, that's annoying because that's red, and times by 3. So you've actually got 3 times 3, which will give you one of the faces at the front, times 3. That would be 3 cubed. And that would equal 27. There are 27 cubes in a Rubik's Cube. If you have one in your house and you have a spare 5 minutes to kill, yeah, you can count the cubes in Rubik's Cube. There are 27 of them. So 3 cubed is 27. You can make a cube out of that number. I can show you 2 as well. So 2 times 2 times 2, that would be written like this, 2 cubed. And you've got 2 that way, 2 that way. I'm going to try and draw this as best I can. Bear with me. This could go either terribly wrong or terribly right. Get my 2 squares there. Drawing the corners up. There you go. You've got a 2 high, 2 wide, 2 deep, and it is 8. You can't really see that, but if I break them up into cubes, just take my word for it. 8 is a cube number. 27 is a cube number. So have a look at this. The error I think that everybody does when they're rushing through an arithmetic paper is you look at this and you say, that's 3 times 3. And you just hammer through it. But there's a couple of reasons why that would never really be the case. Within a Year 6 SATs paper, they're not going to ask you 3 times 3. They're not going to be that generous on question 16 to ask you that. And if they were going to ask you 3 times 3, they'd just write it like this. And then you'd have to answer it. So it's obviously not that for 2 reasons. You're not going to get that simple of a multiplication and then just write 3 times 3. We should be noticing that we've got that little 3 up there. So I'd be writing it out, 3 times 3 times 3. Underneath, I would be taking my steps to do 3 times 3, which I know is 9 times by 3. Break it down into each little bit. Equals 27. Write it in the box. Give yourself a mark. Tick. You might even remember that's the number of cubes in a Rubik's Cube. Next one. There's a BODMAS order of operations element to this, but let's just treat this as a unit on its own, which we should be doing. 6 squared is the same as 6 times 6. I think we'll bring that add 10 down as well. And we think about our BODMAS, multiplication comes first, 36, add 10, 46. It's actually testing two things there, that you can understand what a square number is and you do the multiplication before you do the addition. Another mark, well done us. Here's a question from a reasoning paper. Question 10, write the missing square number to make this addition correct. So we have 8 squared. We have the total, 73. And we're going to work that out bit by bit. First things first, let's get this sorted. Rationalize that. 8 squared is the same as 8 times 8, which is 64. So now we know that number 64 in there. 64 add something is 73. The difference of those two numbers is 9. But we need to work out what the square number is. It's not 8 squared add 9 squared. If I'd actually put 9 in there, that would be equal to 81. 9 times 9 is 81. So we know that total needs to be 9. We need to think, okay, what multiplied by itself would equal 9? And you know it's not going to be a very high number, because even if we go to, say, 5 as our trial and error, and we say, oh, I wonder if it's 5. Well, 5 times 5 is 25, so we know that's too high. So we're going to come down. It's not going to be 1. 2 times is 4. 3 times 3 is 9. So run that through. 8 squared is 64. Add 3 squared is 9. And then 64 add 9 is 73. And you give yourself a mark. So it's asking you to actually work out the square root or to do a trial and error, but it's really testing, do you know your square numbers? And that is it. So there's everything you need to know about square numbers and cube numbers. Please don't get confused between... Well, some people get confused when asked if a number is a square number. Now, a square number is only something you can draw in a square. However, you could square whatever number you want. So we already talked about number 8 down here. 8 is not a square number because we can't draw it in a dot array, and no number multiplied by a number makes 8. But you can still square 8 itself. You can still do 8 squared, which is 8 times 8 equals 64. But it's 64 itself that's the square number, not 8. You can square any number you want. You can square 251. You can square any number you want, but it doesn't make 8 a square number. The result of it is, because you could draw, I'm not going to, but you could draw 64 dots in an array, 8 along and 8 down, and fill it all in, and that would make 64 a square number. Hopefully that makes a bit more sense to you. Hopefully when you see that in an arithmetic paper, you can tick that one off pretty quickly, or even a reasoning paper. This particular question is from the 2023 SATS paper. I don't know whether it's reasoning 2 or 3, but either way, it shows you that the government are really interested in everybody knowing their square numbers. It's definitely a theme that's going to continue, and we can be pretty confident that a square number question is going to be in definitely the arithmetic, but maybe the reasoning paper in 2024 as well. Hopefully you appreciate the video. If you did, drop me a like. Let me know what other topics you'd like to see. I'm going to aim to cover everything in the curriculum. It's going to take me a while, but we'll get there. Subscribe, and if you know somebody who's struggling with square numbers, maybe just share this video. Just drop them the YouTube link. See you soon. Ciao.